Section 0-11 is on simple probability and odds. Probability is the ratio of the number of favorable outcomes to the total number of possible outcomes. Remember, a ratio is just a fraction, and if I were to use easier words than favorable and possible, I could say it's what I want divided by what is possible. And the sample space is the list of all of the possible outcomes. Let's take a look at a couple examples here. So a die is rolled. Find each probability. You should all be familiar with a pair of dice or what a single die looks like. It's basically a cube with dots 1 through 6 on it. So what is the probability? And here's the notation we use. What's the probability of rolling a 6? Well, on a die, there is only 1 6, but there are 6 possible sides. So the probability is 1/6. Number 2, what's the probability of rolling an odd number? Well, on a die, there are 3 odd numbers, 1, 3, and 5, and there's a total of 6 numbers, so 3 over 6, and we need to reduce that to 1/2. Here's another example. A bag of marbles contains 3 red, 6 blue, 5 green, and 2 yellow marbles. Find each probability. So what is the probability of choosing a red marble? So there are 3 red marbles in the bag, and altogether there is a total of 16 marbles, so that would be 3 out of 16. Number 2, what's the probability of drawing out a green or a yellow marble? So how many of the marbles are either green or yellow? Well, there's 5 green and 2 yellow, so that would be 7 out of the 16. So the probability of drawing a green or a yellow is 7 out of 16. Number 3, what's the probability of drawing out a marble that is not blue? So there are 3 red, 5 green, and 2 yellow. Those are not blue. That's a total of 10 out of the 16 total marbles. Reduce that fraction, or 5 out of 8. A tree diagram is a visual representation of all of the possible outcomes. Let me show you an example. A school's uniform consists of a plaid or gray skirt and a white, blue, or black polo. Draw a tree diagram to determine the number of possible outcomes. So we're going to start with kind of like 3 columns here. So I'll give my skirt options in this column, my polo options in this column, and then the list of all of the possible outcomes over here. So for a skirt, I can have either a plaid or a gray, and do spread them out a little bit. And then for polos, I can have a white, a blue, or a black with the plaid skirt. And I can have a white, a blue, or a black polo with the gray skirt. Now the list of all possible outcomes, I think I'm going to abbreviate here. So I can have plaid, white, I can have plaid, blue, and I can have plaid, black, I can have gray with white, gray with blue, and gray with black. Oops, I think I abbreviated that BK. There we go, black. So how many total possible outcomes are there? 1, 2, 3, 4, 5, 6 possible outcomes. So 6 possible ways to pair up 2 different skirts and 3 different polos. Now an easier way to do this, kind of an algebraic way, is called the fundamental counting principle. It says that if event M can occur M number of ways and is followed by an event N, which can occur N number of ways, then event M followed by event N can occur M times N ways. I know that sounds confusing. Let's take a look at an example here. For an ice cream sundae, you can have chocolate, vanilla, or strawberry ice cream, hot fudge or caramel sauce, and either nuts or no nuts. How many choices are possible? So we could do this by drawing out a tree diagram with one column being ice cream, one being sauces, and one being nuts. But using the fundamental counting principle, I would say I have 3 different choices for ice cream, and I have 2 different choices for sauce, and I have 2 different choices for nuts, either nuts or no nuts. Multiply those, so I have a total of 12 possible ice cream sundaes that I can put together. And our last concept here is odds. Odds is a little bit different from probability. It's the ratio of favorable outcomes to unfavorable outcomes. In other words, what I want divided by what I don't want. Remember, probability was what I want to what's possible. This is what I want to what I don't want. So again, a six-sided die is rolled. Find the odds of each event occurring. The odds of rolling an odd number. Well, on a die, there are 3 odd numbers and there are 3 not odd numbers. And usually when we write odds, we use a colon like this. So what I want is an odd number. What I don't want is a number that's not odd, so there's 3 to 3. Reduce that as you would a fraction, and that would be 1 to 1. What are the odds of rolling a number greater than 4? Well, on a die, there are 2 numbers that are greater than 4, a 5 and a 6. So what I want, there's 2 of those. What I don't want is a number that is not greater than 4. So that would be the numbers 1, 2, 3, and 4. And there are 4 of those. Again, think of that as a fraction and reduce that to 1 to 2. So in this lesson, we took a look at simple probability and odds, probability being the ratio or a fraction of what I want to what's possible, and odds, the ratio of what I want to what I don't want. We also looked at ways of drawing a tree diagram and using the fundamental counting principle.